Okay, we're just going to play with a couple more just to make sure we understand what we should be doing with these. So this gets a little bit more difficult, just that it's got more layers to it, basically. So I could look at this and say, okay, so I could multiply the top and bottom by that trinomial that's over there, and the top and bottom over here by this binomial. But I have a feeling that this could be factored and make my life a little bit simple. So let's try it and see what happens. So I have the 5 in the top, and the bottom multiplies to 6, adds to 5. That's going to be x plus 3 and x plus 2. And I'm adding to n x plus 3. And I was right. My instincts were right. You'll notice that this has an x plus 3 and this also has an x plus 3. So I'm halfway to having a common denominator already. The only thing missing is an x plus 2 in this fraction. So I'm going to multiply this fraction by x plus 2 on the top and bottom. But because both pieces are already in the first fraction, I don't have to alter that first fraction at all in order to be able to add them. So I have 5 over x plus 3 times x plus 2, and I'm going to go ahead and distribute that 2, so that becomes 2x plus 4, that I'm adding x plus 3 and x plus 2 with my denominator. So now I have like denominators, so I'm going to add like terms that are in the numerator. So my 2x doesn't have anything like it, so it's just 2x. But my 5 and my 4 can be added together, so that becomes plus 9. With my denominator as it was, and x plus 2. Okay, so you can see that we have to be careful because we can't just automatically jump into multiplying the top and bottom and all of that. We want to check and see if actually there is a factor involved already before we continue on. Okay, so the next one let's look at. Well, we're going to go ahead and check that again and see if there's things that we can factor out. So we have a 12 here. And we have, 15 and 3, they're both divisible by 3. So let's pull that 3 out. And that becomes 5x minus 1. And then over here, we have a 10 and a 2. And they're both divisible by 2. So let's pull that 2 out. So that becomes 5x minus 1. And sure enough, I find that I have a 5x minus 1 already in there. And with this one, I also see that I have 12 over 3. These things are both divisible by 3. That becomes a 1, and that becomes a 4. So I'm actually looking at this fraction, 5x minus 1, plus this fraction, 2 times 5x minus 1. So really all I have to do, the only thing missing is a 2 in the first fraction, because this has the 2 and the 5x minus 1. So if I multiply the top and bottom over here by 2, I should get like denominators and be able to add the numerators. So this becomes 8 over 2 times 5x minus 1 plus 1 over 2 times 5x minus 1. And when I add 8 and 1, I'm getting 9 over 2 times 5x minus 1. Now if this 9 had turned into an even number, say it turned into 10, then I could simplify right here. And that would have turned it into something smaller. So you kind of want to look and see if you can simplify in the beginning and also simplify at the end, because at any point in time we want to try and get it in as simple terms as possible. So we have 2 final questions to look at. Okay. The reason I pulled these is because the statement that it starts with, it says if x does not equal 6. Well, why would x not be able to be equal to 6? Well, if you look at the denominators, 6 would cause both of those denominators to equal 0. And if our denominator equals 0, we know that the function's undefined. This is actually our vertical asymptote, is x equals 6. That's why x can't equal 6, because x equals 6 is the line that the graph appears to approach but never actually touches. Okay, so let's go ahead and sum them. Remember, the word sum means adding. Okay. I already have like denominators, so all I have to do is add my numerators. So I have a 5x and a 3x, which gets me 8x. The 7 is the only constant, and I have x minus 6 as my denominator. So I just wanted to bring that to your attention, what that beginning part of that statement was saying. And the next example has another one of those beginnings. So in the second one, it says x can't equal 3, and it can't equal negative 3.5. Well, if x equaled 3, 3 minus 3, it would turn this denominator into 0. And if x equaled negative 3.5, 2 times negative 3.5, it should be a positive 3.5 is what I'm looking at. Sorry about that. So if x equaled 3.5, that would turn that into 7. Minus 7 would be 0. So that means then, again, my vertical asymptotes are equal to x equals 3 and x equals 3.5. Okay, so now I can go, now that I understand what the statement is saying, I can go ahead about doing my subtraction. Remember, what's going to happen with that subtraction is I'm going to change it to an addition problem by attaching that negative sign to the 2. Okay, so there's nothing that can be simplified really here right now, so I'm just going to work on getting a like denominator. So I'm going to multiply the top and bottom over here by x minus 3, x minus 3. So that gets me 6x minus 18 over x minus 3 times 2x minus 7. And now that I've attached that negative sign to the 2, I can make this as an addition problem. And over here, I'm going to multiply by 2x minus 7 in the top and bottom, so that I have like denominators. So negative 2 times 2x is negative 4x, and negative 2 times negative 7 is positive 14. And my denominator is x minus 3 and 2x minus 7. Okay, so now that I have like denominators, I can add like terms in the numerator. So I have a 6x and a negative 4x, which gets me 2x. I have a negative 18 plus 14. So negative 18 plus a positive 14 would be negative 4. And then that gets me my denominator is x minus 3 and 2x minus 7. Okay, so we have done simplifying. Last week we did simplifying rational expressions, multiplying and dividing rational expressions, and this week we did adding and subtracting rational expressions.